Hello, my awesome math students. Today we're starting a new chapter. This is chapter 8. We're going to be talking about volume in this chapter. And with this chapter, because we're doing volume, we're going to have a lot of formulas. I would suggest that as we go through these different lessons that you are at least writing down the formulas a couple of times to help you remember them. Also, you're going to want a calculator handy because most of the formulas that we're going to use are going to get kind of messy if you're trying to do these by hand. We're going to be using pi, for instance, in all of our new formulas. And that's going to be something that you probably don't want to do without a calculator. So if you don't have a calculator, take a look on your Chromebook, see if you can find where to get one on there. If you don't know how to use some of the stuff in your calculator, please make sure that you ask because it'll make your life a lot easier during this unit if you know how to use your calculator well. So today we are working on the volume of a cylinder. We are just going to take one shape at a time, and today's shape is a cylinder. A cylinder looks like this picture that's on the screen right now. Cylinder is like a soup can or a can of soda, something like that. The bases of a cylinder are circles. Those are the parallel sides. And then we also can measure the height of the cylinder. The area of the base, because I said it's a circle, you know that to find the area of a circle, it's going to be pi r squared. That's how we find the area of a circle. And if you didn't remember that, please write it down somewhere. When we look at this volume formula right here, this is a very general formula for volume. It's finding the area of the base times the height. We could also use that for prisms. The important thing that I want you to notice here is that I've got two letters that are both capital letters. When we've talked about formulas in the past, I've said that it's kind of a picky thing about if you use a capital letter or not. Capital letters are for formulas, like the V's for the volume formula. The capital B there versus just a lowercase b is because I had to use a formula. I found the area of the base. It's not just a measurement. I did something to get that capital B. The height, lowercase because it's just the height. I could measure that. Now, knowing that the area of the circle is pi r squared, I could rewrite this formula to look like this. Instead of that capital B, I could use pi r squared, and then I would also still have that h that's getting multiplied there for the height. That's the formula that I tend to start with, but that capital B times h is a very general formula that works for a lot of different shapes. So in this one, I've got this cylinder that has a radius of 3 meters and a height of 6 meters. If you don't remember, the radius is this right here. It goes from the center of the circle to the edge of the circle. If I was looking at going all the way across a circle, that's called the diameter. And you're going to have to be careful because sometimes they are going to try to be tricky and give you a diameter instead of a radius. So make sure that you're always looking for the radius. Our formula here is area of the base times the height, and that area of the base would be pi times the radius squared. The radius is 3, and then the height is 6. Now, you know order of operations. You know that exponents have to come before multiplying. You can't multiply pi times 3 and then square that whole answer, right? A lot of calculators are getting pretty good with like order of operations. So if you would just type this in on some calculators, you'll get the right answer. On some of them you won't though. So I need your brain to be the smart one in the relationship between you and your calculator. You would do 3 times 3, which is 9. Personally, I do a lot of the numbers first and I multiply by pi at the end. So 9 times 6 would be 54. Then I would have 54 times pi. And they even sometimes write these answers in terms of pi. That means it just says that I didn't actually multiply it by pi yet because right now I have a nice answer. And this is an exact answer. 54 pi is exact. If on your calculator you would type in 54 times pi or just 54 pi and hit equals, you're going to get 169.646, and then it keeps on going. Okay, pi is an irrational number. It's never going to stop. So if you multiply by pi, you're going to get one of these really long decimal kind of answers. This said round to the nearest tenth, which is this place right here. Remember, we don't just drop everything off after that. I would actually have to look at this number, and 4 is not big enough to make it round up, so it's just going to stay as a 0.6. And our label for volume is going to be cubic measurements. For area, it's square because it's two-dimensional, it's flat. For volume, which is three-dimensional, it's cubic. When I write this, I don't tend to write out the words like that. I would write the meters part, and then I use the little 3. But you do read that as cubic meters, not meters cubed. There is a difference. And again, in math, we try to be as particular as possible. We try to make sure that we are very clear with our explanations. This cylinder happens to be laying on its side. The 15 is still the height. I know that that's not how tall it is, the way that it's laying right now. But what I'm looking for here is the distance between the circles, the distance between the bases. Okay, so for this one, our formula, instead of writing that capital BH, I'm going to write pi r squared h. Let's put in the numbers that we know. There's pi. The radius, again, is given to us. So it'll be 4 squared, and then the height is 15. I would strongly recommend that you do your problems like this. It means you're going to write probably 3 lines of work. The formula, substitute, and then get your answer. And again, I would still use your brain over just typing stuff into the calculator right away in terms of what order to do this in. I would do the 4 squared, which is not 8. If you're not sure about that, go ahead and use a calculator, but 4 times 4 is going to be 16 times 15 times pi. That gives me, actually, I'm going to tell you one more thing here. I'm going to use a squiggly equal sign when I get my final answer here, because this is going to be 753.98223, blah, blah, blah. Can I keep on going? The squiggly equal sign means I had to round it, or this isn't the exact answer. As soon as I actually multiply by pi, I don't have an exact answer anymore. This does say round to the nearest tenth, which is this place right here. So I have to look at this place. Does the 8 make the 9 round up? And it does. When a 9 rounds up, remember this is really like 0.9. When that bumps up, that's going to be 1.0. So this is really going to be 754.0. And I would have a label of cubic feet. Now I know that some people are going to say, well, why do we need 0.0? 0.0 is nothing. And you're right. Except it shows that I actually rounded to that 10th place. If I dropped it off, my answer could have been all the way up to like 754.4 if I just didn't have that decimal after that. Or it could have been as low as 753.5, right? So there's a big difference there, and having that 0.0, again, helps to clarify how specific we were. Now, I know this picture is kind of blurry, I'm sorry. This is a picture of a jar of salsa that's 10 centimeters tall, and there's 4 centimeters in height of the actual salsa that's in the jar. So this says how much salsa is missing from the jar. So if it's a 10 centimeter jar and there's 4 centimeters of salsa, then that means that there's actually 6 centimeters of empty space. And they're giving me the radius again. The radius of this jar is 5 centimeters. So I'm going to put in all the stuff that I know. Pi, the radius is 5 squared, and the height of the empty space is 6. So the exact answer in here, if I would do 5 times 5, that's 25. 25 times 6 would be 150, and then I would still have to multiply by pi. So I've got that 150 pi, and then when I do multiply that by pi, I get 471.23, blah, blah, blah. This is just saying to the nearest cubic centimeter, apparently. If I was going for more decimal places, I would probably have a 0.2 at the end. So this is going to be about, notice they even put the word about right there, about 471 cubic centimeters of empty space in there. By the way, also, 471, this would be cubic centimeters, that's how we would write it. If you ever watch any medical shows and they say cc's, that's what they're talking about is cubic centimeters. Okay, so some of these that are just some basic pictures. We've done several of these now with the radius. What I'm more concerned about are these last two, where it gives a diameter. And it tricks students all the time. And I'm telling you, you have to watch out for this. If the diameter of number 3 is 6 meters, then the radius just halfway across, just this part, is going to be 3 meters. And the height is 18. So I would start with my formula, V equals pi r squared h. Pi, the radius is 3 squared and the height is 18. Again, we are going to do another unit with exponents. I'm telling you right now, people get confused on 3 squared. They want to say it's 6. It's not 3 times 2. I'm talking about 3 times 3, which is going to be 9 times 18. As an exact answer, this would be 162 pi. But I don't necessarily want that answer. And I believe that it says to the nearest 10th. So that means I have to actually take that 162 and multiply it by pi, which gives me, I'm going to go with my squiggly equal sign, 508 point, let me write down a couple of decimals here, 938. Would this be a 0.9 or would it round up? Well, that 3 is not enough to make it round up. So that means this is going to be 508.9 cubic meters. I really think volume is a pretty easy chapter to work with because it's just formulas. If you've got a calculator and you get pretty comfortable with how to use your calculator, you're going to be fine. In number 4, I'm given the diameter is 8 inches, so the radius is going to be 4 inches. Okay, my volume is going to be pi r squared h. Every single problem today, that's your formula. V equals pi times 4 squared times the height, which is 12. So 4 squared is going to be 16 times 12 is 192. To be perfectly honest, I don't need you to write down 192 pi like we wrote down 162 pi in the last problem. You can just take that number and say times pi and get my answer here. So my answer approximately, because I have to round, I've got 603.1857. I'm going to keep on going a little bit because I want you to decide, is this going to be a 0.1 or a 0.2? That 8 right there, that's enough to make it round up to a 0.2. Sorry, you can't quite see that, but I promise it is. And cubic inches, again, that's what we're looking at, okay? So today you're going to have a worksheet. It's volume of cylinders. It's just crunching numbers. It's practicing this formula. Make sure that you check your answers in Schoology with the answer key. And then when you're all done, there's a knowledge check or a learning check to just make sure that you're all good with this. If you have any questions, let me know.